starting on this pressure worksheet. So we've got a bottle here. You've got air up here. You've got water here. There's a height of water. There's a hole here in the cap. Right. So first question, state the formula linking pressure difference, height, density, and gravitational field strength. So we know pressure is height times density times gravity or gravitational field strength. So it's H rho G. Pressure is measured in pascals or newtons per meter squared. It's basically it's like force over area. Okay, the other formula for pressure. So this is to do with liquid, and for solids, pressure equals force divided by area. So P equals F over A. Right, so you got that. Got those two in your head, yeah? 1, 2. If you know those two, you've got your pressure sorted out. Right, the pressure difference between the surface of the water and the water at the bottom of right. So they're saying that the pressure, just say for example, it's 0 there. Right, pascals. It's going to be 2,300 pascals here because of the height of the water, this H. Calculate the depth of the water. Give your answer in centimeters. So what we're going to do is, we know the pressure difference is 2,300. We know, no, we don't know the height. We know the density, and we know the gravity is 10. So 2,300 equals H times 10,000. So H equals 2,300 over 10,000. That's gonna, it's in centimeters, so that should be 1212 0.23 meters, but they've asked for it in centimeters, so it's going to be 23 centimeters. Right, with physics, get used to the formula, how to rearrange them. Okay, so can you see what we've done? We've shown first step, and then you've shown the second step, and then you've rearranged it and given the answer. And just remember those steps. Physics is a bit strange when it comes to that. Right, 3 holes are made in the bottle at positions A, B, and C. A, B, and C. Right, so you've got a hole in the cap, you've got a hole here, B and C. Draw a line on the diagram to show the path of the water leaving the bottle from hole A. So there's less pressure. So it's not going to go as far, so it'll do something like this. So it's not going to go as far as this. Right, explain the path of the water leaving from the hole A. 2 marks. So the pressure, right, can you see this height here? This height is less than this height of water. So that means there's more pressure here, down here, than up here. So pressure is lower at A. Force acting on the water So the force here at this point A here, the force at A is less. So force at A is less. So force acting on the water at A is less. So water leaves with a lower kinetic energy or speed. Because remember, kinetic energy equals a half times m times v squared. Right. Hole at C is the same depth, but on the opposite side. Explain the shape of the path leaving the bottle from hole C. Right. So it's going to be whatever that distance is, it's that distance. So it's going to do this, right? Because the pressure here is acting the same in all directions and it's at the same height. So we need to write that down. Explain the shape of the path of water leaving from hole C. Right. The path is identical, but the path is the same, is identical. They've used the word identical. Right. Why? Because the pressure is the same. This is like, it's a really good question to wrap your head around, actually. Because the pressure is the same, the speed or the force, the speed of the water leaving is the same. And the reason the pressure is the same here is because pressure acts equally in all directions. Right. So just why there's a hole in the cap of the bottle. Alright, okay. To allow air to enter. Otherwise, what would happen is no water would come out, because the pressure there and there needs to be the same. As soon as little bit of water's come out, the pressure there inside the bottle would be less, so this could not come out because higher pressure would be holding it in, unless the bottle collapses for some weird reason. Anyway, let's move on. Right, next question. So we should be getting a hang of these now, hopefully. Diagram shows an ice cube. There's your ice cube floating at rest in the beaker of water. State the value of the resultant force on the ice cube. So the force, the mass or the weight, and the pressure from the water, the buoyancy, if that's the right word, is equal because it is at rest. So there's no resultant force. So it's 0 newtons. Right. Diagram 2 shows an ice cube being pushed down. Is nice. Right. State the formula linking pressure difference in the height and density. Right. Okay. So pressure equals height. So remember we said we're going to try to learn it in word form. Density times gravitational field strength, gravitational field strength. Right, I would suggest gravitational, so let's change that. Gravitational field strength is probably a better one to learn. Let's change that P. Let's change that P to pressure. Let's try to learn the full thing, yep. Okay, that's that done. What's next? Right, the bottom of the ice cube is below the surface. Show that the pressure difference between the bottom and the surface of the water is about 400. Right, so we know pressure equals height times density, which is rho, this is a weird P, and G. So let's substitute the values in. Height is, right, we need to convert the, no, let's leave it. 0.041 times, that's the density, so remember this is density, 1000 times gravity. So you would get 410 pascals. Okay, so okay, that's simple, straightforward. State the formula, right? Remember those two formulas that we look at. Pressure is height rho g, and pressure is force over area. Just remember them two. So P, no, we said we're going to learn the pressure equals force divided by area. Right. The area of the base is that many square meters. Calculate the upward force. Right, so remember pressure, let me get rid of that, start here. So P equals F over A. P is 410. What this said is approximately 400, should we? Let's stick to 410. F over area, which is 0.0017, and then we rearrange that, so we say F equals 410 times 0.0017, which equals 0.68 newtons. Let's double check that. Well, according to them, 410 times 0.0017, right, this is 0.697 if you use that, but they've used, by the looks of it, 400 instead of 410. Yeah, you can use this value, but in the mark scheme they've used 400, that's where they've got that from. So it's win-win. Explain why the ice cube will accelerate upwards when force is removed. Right, that means because the resultant force is upwards. Why? Because, why is that? Because the upward force is greater than the weight of the cube. So the weight of the cube and the upward force when it's still is like this. Yeah, it's equal. When you push it down with your finger, what happens is this sinks. So now the force, when you let this go, the force acting up is bigger, so it'll accelerate upwards. All we want is the resultant force at this level. We don't need to do anything else. Right, right, we'll call it quits here on this one actually. Yeah, we'll do this. This is like a balloon one. Okay.